that is closest to number 1 is 2, and this is given as the sum of the first 3 elements of this array. Okay, so how we're going to solve this problem? Yeah, so we can solve this problem since this is very similar problem to the classical 3-sum problem or even 2-sum problem. We can use 2 pointers method to solve this problem. The idea is that we just first of all have to sort the array, and then we have to approach from the beginning and from the end, and then just compare the values. If the sum is less, then we just have to increment it from the left, and then if bigger, then decrement it. Shift to the left. So the idea is going to be the same, but however, since we have to find 3 numbers, this can be done at least in the worst case will be quadratic. So let's do it. So first of all, we have to check, right, if there are at least 3 numbers. So if the size is less than 3, so just return 0, right? Cool, that's done. And as we said that we have to sort the array, so it's going to be begin nums dot, and that's it. So the next thing is that I really like and advise it here, since we're going to have a return value here. So always just from the beginning, just declare it as soon as possible. Why? Because whenever we'll have right now, you will see later that the body of the function, there will be several brackets here, the multiple brackets, and then if you want to put the return value, it will be quite a task for that. So just say return result, right? And then of course somewhere here just say integer result. Cool, it's done. So let's do it. So the first loop minus nums dot size, I++. Cool. So here we have to declare 2, as we agreed that we are going to use 2 pointers. Let's do it. So j is equal to I+1, and also k, let's say it's going to be numbers of size -1. Cool, done. So right now we have to go through so what we are going to do here is we're going to run this loop as soon as there's 2 pointers meet. So that's the idea they're behind the 2 pointer method. And so how we're going to proceed from here? It's first of all, we have the sum, right? What we have to do is let's sum the numbers first. Nums I plus nums, so it's going to be k and it's going to be j, right? So what we are actually required to do is to just find the sum, right, and return it. So, and the idea is that since we're given target, and since we have to find this sum should be as close as possible to target, it makes sense to consider the difference of these numbers, right? And the idea will be here to minimize this difference. So let's say we have, say, integer, let's say diff is equal to this one, and the idea is just to minimize it. So this, you know, guys, how to minimize it. The simple way is just declare a variable, let's say integer, let's say min diff is equals to, I mean, the max one, right? This is a maximum integer possible in C++, at least. There is a library climits.h. So good. Of course, now we have to compare it. If, let's say, the given mindiff, right, is bigger than. So if it's bigger than, so we have to consider actually the absolute value, because dealing with the min. So let's say we have absolute value, right? And that if it is less than this and bigger than this, and just say it's equal. Just assign it, sorry. This is a simple way of finding the minimum, right? So as soon as we update it, right, this means that immediately we have to update the result within this if block, right? So it's going to be target minus, in this case, it's going to be min diff, right? So, oh, sorry, it's going to be not min diff, of course, it's going to be diff. Why diff? So if you look actually, let's say, into this expression, so whenever we have to find this one, right? So whenever we update the min diff, right, to be absolute value of, so the result should be this one, the sum. And this one actually equals to the target minus difference, right? This is like, it should be obvious. So, okay, so what we do next? So the next one is, depending on the difference, right? We have to shift the indices right now. So if difference, right, is bigger than 0. So what we do here, we have to increment the j. So why j? Because you can see here, so the idea is to minimize the difference, right? Because it's bigger than 0, and then let's try to the difference, right? Try to minimize it. So in order to minimize the j, this number is the leftmost initially number, and it's this number is less than this one, meaning like, because since our array is sorted. So in this sense, in order to actually minimize different, we have to maximize this one, right? And this means that we have to maximize this number, because we can't maximize this nums k already, right? So because it's already a given sum, it's already in the sum, it's maximum. So let's say okay. So, however, we can consider another case here, and we have to. So let's say if difference can be, if what will happen if. So it's obvious that here we have to, since it's here, so we have to shift to the left, right? From the right to the left. Meaning like we are trying to increase the difference. So what will happen, okay, if the difference is 0? So in this case, if difference is 0, then target will be the desired sum, right? So just return the sum here. Okay, we can just return the target. Cool. I think that should be all right now. Let's try to run this code. Oh, of course. Okay. Typo. Good. It works. Try to submit it. Yep. It works. The runtime is 8 milliseconds, so faster than 80% of C++ submission. Not bad. I hope you guys enjoyed the video, the solution. Please like the video and subscribe to my channel. And let's see you in the next video. Bye.